Okay, 8-5 day 2, a new formula coming at you. So yesterday you learned how to do volume of a cylinder. Today we're going to solve a region between two curves. Revolve that region that's between two different functions over an axis. And you're going to see this is not going to be a cylinder. So I'll do my best. So let's just say we've got function G. Looks like this. And I got a different function, function F, let's say looks like this. And I'm just going to take a region from here to here. I'm going to take this region and revolve it around that x-axis. Okay, so we'll take our sample rectangle, and we're going to revolve the whole rectangle around the axis. And if you have any vision here, you can see this thickness coming around. So there's a big gap in here. And then the solid part of the rectangle. So what's going to happen is you're going to get what's called a washer. So think about the washer with the hole in the middle. That's what this is going to give you. So I'll do my best at drawing it. So we go all the way around the x-axis. On the bottom. And then it has thickness to it. I don't know if I want to try the thickness or not here. Kind of. My art skills are lacking, but you get the idea that this is going to be a washer with a little bit of thickness to it, and that thickness is the width of our rectangle here. So anyway, we do get what's called a washer. And now we want to figure out, well, what's the formula for the washer? We know the volume formula for cylinder is pi r squared h. Well, with a washer, what you need to do is think of it as a big outside cylinder and then minus the inside cylinder, creating that hole in the middle of it. So the volume of a washer is the volume of the outside cylinder minus the volume of the inside cylinder. Okay, so let's think about it. I want to go back and just look at the rectangle now. So this rectangle. My outside cylinder would be if I didn't have this bottom function at all. My rectangle went all the way to the x-axis and rotated around. So I'm going to call the distance from the axis to the top of the rectangle. That's going to be my R1, radius 1. That's going to create my solid cylinder. So that volume will be pi times R1 squared times height, and the height is just the dx here. Now, the inside cylinder, that radius goes from here to the bottom of the rectangle. That goes around, and that's what we subtract off, creating that hole in the middle of the washer. So I'm going to call that radius 2. So that formula is pi R2 squared h. So between these two formulas, we're going to basket factor out the common terms. We've got pi and h in both of them. So if we factor out pi and h, that will leave R1 squared minus R2 squared. So turning this back into a calculus formula to get the volume of the washer, you will do the integral from, well, your region A to B, whatever boundaries you have, of pi. We got r1 squared minus r2 squared. And our height of our washer, our cylinder, is the thickness of the rectangle, which we call normally dx. Or I'm going to go h right now. H. So there's the general form, pi r1 squared minus r2 squared h. So depending on which way that rectangle is, when we rotate around the x-axis, we have x boundaries, x is in our radius, so x is in the equations, dx on the end. So with a vertical rectangle perpendicular to the x-axis, your A is an x value, your B is an x value, your equation is in terms of x's, so your R1 will be the top equation, your R2, which we have to square, will be the bottom equation. So it's still top minus bottom, but they're both squared first. And then the h will be a dx. Okay, if you're going around the y-axis, so your rectangle is now perpendicular to the y-axis, which means technically it's laying on its side. I could have drawn it that way. Your A has to be the y value. Your B has to be the y value. Your R1 will be the right equation, because that'll be the longest one. Your R2 is going to be your left equation, so right minus left, and then it'll be a dy. So same equation, just here you want to see y boundaries, y is in the radius, dy, make sure R1 is the right, R2 is the left. If we're going on the x-axis, you want x boundaries, x is here in the radius, R1's the top one, R2 is the bottom one, and dx. So I'll do one of each, and I think it'll be okay. Just be careful with the algebra. The graph is boss, the rectangle is boss. So make sure you graph good and take your time. So we want the volume of the region bounded by y equals e to the point 2x and y equals 0.5x plus 1. So bounded by, given just these two equations, that means there should be two intersections, at least two intersections. And we're going around the x-axis. So I have these in here already. E to the point 2x, 0.5x plus 1. I've fixed up the window so I can see the gap. Otherwise, when I went 10 to 10, these were very close together. I couldn't see the gap. So I just reduced my y-axis to stretch that out. So I can see that the line goes on top of the e function. So graph looks like this. And then the intersection, we'll find that intersection here first. Second, calc, I don't know if that's on the y-axis or not. 5, I can't tell. Enter, enter, and we're going to come back here. Oh, negative 2.2 times 10 to the negative 13th. That's essentially 0. So 0, 1 is that intersection. So this one is crossing at an x value of 0. Now I got to find this intersection. Do the same thing. Second calc, intersect, and then slide down here. Okay, 8.09 for the x value. So we're going around the x-axis, so I want my rectangle to be perpendicular to that. So now I can see my R1 is the top one. That's my line, 0.5x plus 1. R2 is the bottom, that's e to the 0.2x. I've got my boundaries. Now I'm ready to write the volume equation. So the volume can be found by doing the antiderivative from 0 to 8.09 of pi. I need R1 squared. So that's a binomial, so I need to put it in parentheses. Minus R2 squared, e to the 0.2x, the whole thing squared, dx. Okay. So at this point, we do have to square first, and then we can distribute that pi to both of them, and then do antiderivative. Or you can just leave the pi out in front, carry it along, and do the squaring and antiderivative, and then multiply by pi at the end. It doesn't matter, as long as it gets not lost. So first of all, do I need to FOIL this out? I could FOIL this out and get 3 terms, but would I be able to do a power rule here? And if I think about it, the derivative of the inside is just a 0.5 or a 1/2. So I could put a 1/2 next to the dx, multiply by 2, and then just do a power rule, which I think I'm going to do that instead of FOIL. It's quicker. If you didn't see that, you would FOIL it out and do each of the 3 terms separately. And then over here, while power to a power, I do have to multiply. So 0.2 multiplied by 2 is going to give me a 0.4x. So this term is just going to go e to the 0.4x. So they're both now really ready for antiderivative, so I'm going to do that. I'm going to carry along my pi. Antiderivative here, I'm going to do power rule. This one needs a 0.5 next to its own little dx over here, so a 0.5, that gets thrown away. That's a 1/2, so I need a 2 out in front that's going to carry along. So 2 0.5x plus 1 cubed times 1/3 makes that 2/3 minus, same thing here, I need a 0.4 next to the dx, that gets thrown away, which is 4/10, so I need a 10/4 out in front, which is 5/2. So I'll carry along the 5/2, e to the 0.4x, and then all of that will have a 0 and an 8.09 substituted in. So just take your time, write down a few things, and then calculator skills. So I'm going to go to the y equals, type this in, and let the table give me these values. So I can clear that out. I'm done with that. Clear that. Okay, I've got pi, parenthesis, and 2/3, parenthesis, 0.5x plus 1 cubed minus, I'll go 2.5 e raised to the 0.4x, parenthesis, and then I'm ready. Table set, 8.09. So I'm getting 69.19. You do have to show me both of these numbers. Minus, and then the 0. That's not 0, so I am going to get something. 0. A negative 5.76. So now adding those together, 74.95 cubic units. So just keep track of the algebra and you should be good. Let's try another one. Okay, number 2. We want volume of the region bounded by y equals square root of x and y equals 0.5x. And this time we want to revolve around the y-axis. So, graphing this one, I did not type these in. So we got, clear that out, square root of x, 0.5x, so 6. Okay, you can see that. I can get rid of, if you want to see more clearly what's happening there, I can tell I want to stretch this vertically, so I want to get rid of some of the y-axis. So if I go like -2 to 3, see what I get. Okay, that's there. So got a line that's going through the origin, and then this square root graph starts at the origin. So I do need this intersection. So 0. Oh, I want y. Like, yeah, we're going around the y-axis. Oh, I almost missed it. Rectangle. So I do want this intersection, but I want the y value, not the x value here. So the origin's not a problem. I wouldn't have got that wrong. So second calc, intersect. Boom, boom. Y value is 2, x value is 4. We want the 2. Okay, so because my rectangle is horizontal here, my R1, just like before we would go right minus left, R1 is the right equation, so it's the line. So R1 is the y equals 0.5x. But remember, I need to see y's in my equation, so I've got to kick this around and get it x equals. So dividing by 1/2 is multiplying by 2. X equals 2y. So we're using the 2y. The R2 is the left equation. That's the y equals, y equals, I'm going to go x to the 1/2. And again, I got to get it x equals, so I'm going to square both sides. So x equals y squared. So I want to see all y's in my antiderivative equation here. So to get volume, antiderivative from 0 to the washer formula, and it's a washer because there's a gap. There's a gap between the rectangle and the axis. Anytime this gap is here, that's a washer. If the rectangle goes all the way to the axis, that's going to be a cylinder. So the gap is what determines that it's a washer. So pi parentheses R1 squared, so that's 2y, the whole thing squared, minus, I need the y squared squared, and then dy for the height. So I'm going to simplify those first before I do antiderivative. So this is going to be a 4y squared. This is going to be a y to the 4th. So this one's pretty easy to do the antiderivative. So the pi carries along. Antiderivative here is add 1 times by reciprocal. So that will give me y cubed. Keep the 4 times 1/3, so 4/3. And then it'll be y to so we'll 2, x to the 5th. And we want to go to 2. And that is 0. So 13.40. All right, enough to get you started.